Um, Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter Indefinite Integrals. So any doubts, if you have in any steps, then please write that in the comments. We shall obviously clarify them in the subsequent videos. So here it is told that integral 2 minus tan x by 3 plus tan x dx. So we can write tan x as sin x by cos x. So this is integral 2 minus sin x by cos x by 3 plus sin x by cos x whole integral dx. So now we can take LCM. So LCM will be cos x, and cos x we can cancel out. So then this will become 2 cos x minus sin x by 3 cos x plus sin x dx. Now this 2 cos x minus sin x, that we can write, that is equal to some a into 3 cos x plus sin x plus b into the derivative of this, that is minus 3 sin x plus cos x. So therefore I can say that 3a plus b, that will be equal to 2. 3a plus b, that is equal to 2, and a minus 3b, that is equal to minus 1. A minus 3b, that is equal to minus 1. So therefore I can say, if we multiply this with 3, so then I will get 9a plus 3b is equal to 6. So then if we add them, then we will get 10a, that is equal to 5. So it means a will be equal to half. And if a is half, then b will be equal to 2 minus 3 by 2. That is equal to 1 by 2. So b is also 1 by 2, a is also 1 by 2. So therefore, we can write this integral I. Let's call this integral as I. So this integral I can be written as integral half of 3 cos x plus sin x divided by 3 cos x plus sin x to dx plus integral half of minus 3 sin x plus cos x dx by 3 cos x plus sin x. So now here, this we can write it as, this will be half integral dx, then plus this will be half integral. If I take this as t, this will become dt. If I take, let's say, t is equal to 3 cos x plus sin x, then I can say that dt will be equal to minus 3 sin x plus cos x to dx. So this will be half of bt by t. This will be log base et. So integral dx is x. So this will be half of x plus half log base e to t. Now t is 3 cos x plus sin x plus c. And this will be mod, obviously, log mod t. So then, therefore now this can be written as half we can take as common outside. Then I can write x plus log base e mod of sin x plus 3 cos x and plus c. Therefore, if we compare this with this, which is equal to, it is told half of alpha x plus log base e mod of beta sin x plus gamma cos x, then plus c. Then we have to find the value of alpha plus gamma by beta. Alpha plus gamma by beta value we have to find out. So from here we can say therefore alpha is equal to 1 and beta also is equal to 1 and gamma is equal to 3. So this is 1 plus 3 by 1. This is equal to 1 plus 3, that is 4. So option D is the correct answer. So this integral we can write it as integral 6 cosec square x dx divided by 1 minus cot x whole square. Now here if I take cot x as t, then minus cosec square x dx, that will be equal to dt. So this will, this we can write it as minus integral 6 dt by 1 minus t whole square. Now if I take 1 minus t as z, then minus dt, that would be equal to dz. So this integral I can write it as 6 dz by z square. So therefore the integral I will be equal to 6 into z power minus 2 plus 1 by minus 2 plus 1. So which will be minus 6 by z plus c, basically. Z power minus 1 means it is 1 by z only. Therefore the integral I, it is minus 6 by 1 minus t plus c, or I can say it is minus 6 by 1 minus cot x plus c. So this is I of x. Now therefore it is told I of 0 is 3. So I of 0 will be minus 6 by 1 minus cot 0 plus c. Now cot 0 will be 1 by tan 0, which is infinity. So you can write this as minus 6 tan 0 by tan 0 minus 1 plus c. So tan 0 will be 0 only. So this will be 0 plus c. So that is c. So c is equal to 3 obviously, since it is told I of 0 is 3. Now therefore I of pi by 12 we have to find out. Therefore we have to find cot pi by 12 value. Cot pi by 12. So pi by 12 means it is 12 ones are 12, 15 degree. It is 1 by tan 15 degree. Now tan 15 degree is tan 45 minus 30. So I can say tan 45 minus tan 30 by 1 minus tan 45 into tan 30. 1 plus tan 45 into tan 30. So this will be 1 by 1 minus 1 by root 3 by 1 plus 1 by root 3. This will be 1 by root 3 minus 1 by root 3 plus 1. So this root 3 plus 1 I can take it here. So this if we rationalize it, then we'll get as root 3 plus 1 whole square by 3 minus 1, which is 3 plus 1 plus 2 root 3 by 2, which is 2 plus root 3, obviously. So cot pi by 12 is 2 plus root 3. So therefore, I of pi by 12, that is equal to minus 6 by 1 minus cot pi by 12. Let's see. C is 3, obviously. C is equal to 3. So this is I of x plus 3. This will be equal to minus 6 by 1 minus plus root 3. Minus 2 minus root 3 plus 3. So this is minus 6 by minus root 3 minus 1 plus 3. This will be 6 by root 3 plus 1 plus 3. So now if we rationalize it, then we will get 6 into root 3 minus 1 by 3 minus 1 plus 3. So 3 to the 6. So 2, the 2, 2, 3 is 6. So this is 3 root 3 minus 3 plus 3, that is 3 root 3. So I of pi by 12 is 3 root 3. So option D is the correct answer. And here it is told if this integral dx, that is equal to 1 by 12 tan inverse 3 tan x plus constant, then the maximum value of a sin x plus b cos x is. So we can divide the numerator and the denominator by cos square x. So then the integral I, we can say that is equal to integral secant square x dx by a tan square x plus b square. Okay. So now a square tan square x plus b square. Now the thing is, if we take tan x is equal to t, then we can say secant square x dx, that will be equal to dt. So then therefore I can be written as integral dt by a square t square plus b square. A square t square plus b square. So which is equal to you can take b square outside. So this will be 1 by b square to integral dt by 1 plus at by b whole square. You can write this as p square by b square by a square. So we know that integral dx by 1 plus x square by a square, it is given as a square plus x square, sorry. So we can take a square as common actually. Right. Integral dx by a square plus x square, that is given as 1 by a tan inverse of x by a. So then this is by a square. So then t square plus b square by a square. So therefore this integral I can be written as 1 by a square into 1 by b by a tan inverse of p by b by a. So this will be 1 by ab tan inverse of at by b. I, that is equal to, I can say p is tan x. So I can say this will be 1 by ab into tan inverse of a by b into tan x plus c obviously constant. So now if we compare these two answers, then we will get that AB will be equal to 12 and A by B, that is equal to 3. So therefore, if we multiply these two, then B will get cancelled. And you can say A square, that will be equal to 12 3 are 36. A will be equal to 6. A will be equal to A square is 36 and B square. If we divide these two, then B square will get, so B square will be 4. Now, therefore, we have to find the maximum value of a sin x plus b cos x, which is square root of a square plus b square. So, which will be square root of 36 plus 4, that is equal to root under 40. So, root over 40, option C is the correct answer. And here it is told to find if this integral equal to a cos theta tan x minus sin theta plus b root over cos theta plus sin theta cot x plus c, where c is the integration constant, then AB is equal to so this integral is given as integral sine power 3 by 2x plus cos power 3 by 2x dx by root over sine cube x cos cube x into sine of x minus theta. So now this sine x minus theta, that can be written as sine a cos b minus cos a sine b. Obviously, it's cos a sine b. So it is sine x cos theta minus cos x sine theta. So this can be written as, if you take sine x outside, sine x as common, then we can say this will be cos theta minus sine theta cot x. Or if we take cos x as common, then we can write it as cos x into cos theta tan x minus sine theta. Now, therefore, this integral I can be written as this 2 we can separate sine power 3 by 2x dx by, then I can write root over sine power sine cube x into cos cube x into cos x. So this will be cos power 4x. Cos power 4x into cos x cos theta tan x minus sine theta. And plus we can write integral cos power 3 by 2x dx by root over is sine x I can take outside. So this will be sine power 4x into cos cube x into cos x minus sine theta. Sorry, this is into cos theta. This will be cos theta minus sin theta cot x. Now this we can write here. This will be sine power 3 by 2x, 3 by 2x dx by this I can take outside. So this will be also sine power 3 by 2x. And this will be cos square x. And this will be root over cos theta tan x minus sin theta. Plus this will be integral cos power 3 by 2 dx, 3 by 2x dx by this will be sine square x into cos power 3 by 2x into root over cos theta minus sin theta cot x. Now these two will get cancelled. Here also these two will get cancelled. So now therefore this integral I can be written as I1 plus I2, where I1 I can write that is integral this 1 by cos square x is secant square x. So I can write this is sec square x dx divided by root over cos theta tan x. Cos theta tan x. Sorry, this is cos theta tan x. This is not theta. Cos theta tan x minus sin theta. So we cos theta tan x minus sin theta. And the integral I2, that is also integral 1 by sine square x is cosec square x. So cosec square x dx divided by root over cos theta minus sin theta cot x. So now therefore the integral I1 that will be equal to, so here if I take cos theta tan x minus sin theta as t, then we can say that cos theta into secant square x dx that will be equal to dt. And in case of in I2 also, in the integral I2, if I take this cos theta minus sin theta cot x as z, then we can say that minus sin theta into d by dx of cot x is minus cosec square x dx, that will be equal to dz. So therefore the integral I1 we can write it as this will be dt by cos theta into root over t, and I2 that is equal to integral dz by this is sin theta, dz by sin theta into root over z. So now therefore the integral I1 can be written as 1 by cos theta to t power minus half plus 1 by minus half plus 1 plus c, obviously plus c1, we can say the integration constant, and the integral I2 that will be equal to 1 by sin theta into z power minus half plus 1 by minus half plus 1 plus c2. So therefore the integral I1 can be written as this is half, so I can say 2 by cos theta into root t plus c1, which means it is 2 by cos theta into root over t, that is cos theta tan x minus sin theta plus c1, and integral I2 that will be equal to 2 by sin theta into root z, where root z means root over cos theta minus sin theta cot x plus c2. So now therefore I1 and I2. So if we add them, then C1 plus C2, I can call it as the integration constant C. So therefore we can say that the integral I that will be nothing but 2 by cos theta 2 by cos theta into root over cos theta of tan x minus sin x and plus 2 by sin theta into root over cos theta minus sin theta cot x sin theta cot x plus c. So therefore hence a is nothing but 2 by cos theta and b is nothing but 2 by sin theta. Now AB we have to find, so therefore AB value will be 4 by sin theta cos theta. Now this we can write sin 2 theta by 2. So this will be 8 by sin 2 theta or 8 cosec 2 theta. So 8 cosec 2 theta. This option B is the correct answer. Here it is told that for x belongs to minus pi by 2 to pi by 2, if y of x is this, integral cosec x plus sin x dx by cosec x sec x plus tan x sin square x, and the limit extends to pi by 2 y of x, that is 0, then y of pi by 4 is equal to how much? So now this cosec x we can simply write it as 1 by sin x, then we will get therefore the integral which is y of x that can be written as integral 1 plus sin square x by sin x if we take the LCM, and this is also 1 by sin x into 1 by cos x. This is 1 by sin x into 1 by cos x plus tan x. It means it is sin tan x into sin square x means sin cube x by cos x. So this cos x and into dx obviously, and then integral this cos x we can take it upwards. Then we can write this 1 plus sin square x by 1 plus sin power 4x. Since y then sin x I can 1 by sin x I can cancel out and into cos x dx obviously. So this is y of x. Now here if we take sin x as t, then y of x that will then y of t will come. Y is a function of t. Y is a function of t, and obviously cos x dx will become dt. Cos x dx will be dt. Then y of t we can say this will be integral 1 plus t square dt by 1 plus t power 4. T power 4. Now here here we can divide by t square, then we will get 1 plus 1 by t square dt by 1 by t square plus t square. Now here this is y of t. So now here if we take t square plus 1 by t square, t square plus 1 by t square, we can say that is equal to t minus 1 by t whole square plus 2. Since why it is t square plus 1 by t square minus 2 plus, okay. And then if we take t minus 1 by t as z, then obviously dt by dt by dt that dz, that is, okay, d of this, so that will be 1 plus 1 by t square into dt, that will be equal to dz. So then y of t, that can be written as integral dz by t square, integral dz by z square plus 2. This is obviously, this is root 2 whole square, so I can say 1 by root 2 tan inverse of z by root 2 plus c plus some constant. This is y of z actually. So now therefore y of t, that will be nothing but 1 by root 2 tan inverse of t minus 1 by t by root 2 plus c. So now t is nothing but sine x. So we can say y of x, that will be equal to 1 by root 2 tan inverse of sine x minus 1 by sine x by root 2 plus c. Now here it is told that limit extends to pi by 2. Limit extends to pi by 2 y of x, that is equal to 0. 0. So therefore I can say, if I put pi by 2 here, then I can say therefore 1 by 2 tan inverse of sine pi by 2 is 1, and it's 1 by sine pi by 2, that is also 1 by root 2 plus c. So that should be equal to 0. So tan inverse 0 is 0 only, so c will be 0. The constant c is 0 only, so then y of pi by 4 I have to find out. So therefore this is 0, so we can just cancel it. So this is the required function y of x, that is this. Therefore y of pi by 4 we have to find. Now y of pi by 4 will be by root 2 tan inverse of is your this tan inverse sine pi by 4, that is 1 by root 2 minus root 2 by root 2. So this is 1 by root 2 tan inverse of this will be 1 minus 2 by, if we take the LCM by 2, that is minus half. So this is minus 1 by root 2 tan inverse half. Or we can say that is also equal to 1 by root 2 tan inverse of minus half. Tan inverse of minus half. So option D is the correct answer. Then here it is told we have to find this integral, that is equal to which one. So here suppose in this integral I, suppose if we take this tan inverse of x cube plus 1 by x cube as t, then we can say, that d by dy of tan inverse y, that is equal to 1 by 1 plus y squared. So this will be 1 by x cube plus, yeah, um, 1 by 1 plus x cube plus 1 by x cube whole square to d by dx of this, which is 3x square, 3x square minus 3x power minus 4 minus 1 into dx, that is equal dx, that is equal to dt. So therefore you can say x3 we can take outside. This will be into x square minus x power minus 4 dx by 1 plus x power 6 plus 1 by x power 6 plus 2. Yeah. Dx, this into dx, that will be equal to dt. Now therefore this I can write 3 into x power 6 I can take as LCM. So this will be x square minus x power minus 4 dx by, this will be x 3x power 6 plus x power 12 plus 1 by x power 6 is equal to dt. So then we can say this will be 3 into x power 6. So this will be x power 8 minus x power 2 into dx by x power 12 plus 3x power 6 plus 1. This will be equal to dt. So therefore, we can say that the integral I, that is nothing but dt by 3. This is nothing but dt by 3 t, dt by 3t. So it is 1 by 3 log base e t, log base e mod t plus c. So this will be 1 by 3 log base e t, that is mod of tan inverse of x cube plus 1 by x cube plus c. So now, and this 1 by 3 I can take in the x exponent here. So this will be log base e tan inverse x cube plus 1 by x cube whole power 1 by 3 plus c. 1 by 3. So then, therefore, option A is the correct answer. And here it is told so here it is told that for alpha, beta, gamma, delta belongs to n, means all these are natural numbers, alpha, beta, gamma, delta. Then if integral of this is equal to this, then where e is this, e is the natural logarithmic base, we know, and c is the constant of integration. C is the constant of integration. Then alpha plus 2 beta plus 3 gamma minus 4 delta is equal to how much? So this x, we can also write it as e power log base ex. E power log base ex. Then therefore x by e, we can write it as e power log base ex by e, which is so minus 1. Therefore x by e power 2x, that can be written as this to 2x. So this will be e power 2x log x base e minus 2x. And similarly, e by x power 2x, that is x by e power minus 2x. This will be e power minus 2x log base ex plus 2x. Now therefore the integral of this x by e power 2x plus e by x power 2x into log x base e dx. So that will be equal to integral x by e can be written as e power 2x log x base e minus 2x and plus e power minus e power 2x minus 2x log base ex plus 2x. Okay, into log x base e dx. Now, if we take this 2x, or we can take this x into log base ex minus x as t, then we can say this will be x by x, since d by dx of log x is 1 by x. So x by x plus log base ex minus 1, that is into dx, that is equal to dt. So it means 1 and 1 will cancel. So it means that log x base e dx, that is equal to dt in this case. So now therefore this integral I, that you can say this as integral I, suppose. So the integral I will be written as e power integral e power 2t plus e power minus 2t into dt. Now e power integral 2t e power integral e power 2t dt, that is equal to, so here if we take 2t as z, obviously 2 dt, that is equal to dz. This will be integral e power z or z dz plus integral e power minus z dz. Therefore, the integral I can be written as this is e power z, or I can say e power 2t plus plus this is minus e power minus z plus c. So this is minus 2t. That means it is e power, the integral I, that will be e power 2t e power 2t. T means it is x log x base e minus x minus e power minus 2t, which is minus 2 into x log x minus x plus c. So now here this can be written as e power 2x log x minus 2x, that can be written as x by e power 2x minus this can be written as e by x power 2x by x power 2x and plus c. Now this is given as this is equal to 1 by alpha 1 by alpha x by e power beta x minus this is 1 by gamma e by x power delta x plus c. This is the integral I. So now therefore alpha will be equal to 1, beta will be equal to 2. But so this is okay, sorry, this will be dt will be dz by 2 actually. Dz by 2. So 1 by 2 I have to write here. 1 by 2 dz by 2. So 1 by 2 will come here. This will be 1 by 2 times of this. 1 by 2, 1 by 2 is there. So if you compare this, then alpha will be equal to 2, beta also is 2, gamma also is 2, and delta also is 2. So therefore, we have to find the value of alpha plus 2 beta. So alpha 2 into 2 plus 2 into 2 plus 3 into 2 minus 4 into 2. So this is nothing but 2 plus 4 plus 6 minus 8. So which is equal to 4. So option D, 4 is the correct answer. And here it is told if I of x that is equal to this 6 sine 2x plus sine x dx. Now that let's say we take integral I1 as integral e power sine square x into cos x sine 2x dx. Now this will be, now here, if I take sine square x as t, then 2 sine x cos x, which means sine 2x dx, that will be equal to dt. So then this will be, for the integral I1, I can write it as power sine square x. Yeah, so cos x into integral cos x into integral e power sine square x into sine 2x dx. And then minus this will be d by dt of cos x, which is minus sine x into integral of this integral e power sine square x into sine 2x dx. So therefore the integral I1 that will be equal to cos x into this will be equal to t, then this will be sine 2x dx, that will be equal to dt. So this will be integral e power t dt plus this is integral sine x. So integral e power t dt. So then this will be cos x into e power t plus this is integral sine x into e power t. Okay. So this will be cos x into e power sine square x plus this is integral e power sine square x into sine x. So therefore the integral I of x, that is nothing but I1 plus or I1 minus integral sine x e power sine square x dx. So which is, so if we add this with this, so this will be cos x into e power sine square x plus integral e power sine square x into sine x dx, then minus integral e power sine square x into sine x dx. So these two parts plus c, obviously plus c is there. So these two parts will get cancelled. So therefore, integral I of x. So therefore, the function I of x is nothing but cos x into, which is e power sine square x into cos x plus c, or sine square x into cos x plus c. So now therefore now it is told that I of 0 that is equal to 1. I of 0 that is 1, then I of pi by 3 will be how much? I of pi by 3 is equal to how much? That we have to find out. Now I of 0, it means I can put x as 0 here. So I of 0 that will be e power sine square 0 is 0 into cos 0 plus c. So cos 0 is 1, e power 0 is also 1, and this is told that is equal to 1. So therefore c plus 1 that is equal to 1, so c will be 0. So therefore I of x is nothing but e power sine square x into cos x. This one is the required function. Now we have to find I of pi by 3. So then I of pi by 3 that will be equal to e power sine square pi by 3 into cos of pi by 3. Pi by 3 means 60 degree. So e power cos 60 that is root 3 by 2 whole square into cos 60 degree that is 1 by 2. So which is e power 3 by 4 by 2. So which means I can write that is 1 by 2 e power 3 by 4. 1 by 2 e power 3 by 4. Option D is the correct answer. Here it is told the integral is ln this is equal to how much? So now this x by 2 power x we can write it as e power log base ex. So therefore x by 2 that will be this by 2. So whole power x so this by 2. This 2 also I can write e power log base e2. So therefore x by 2 can be written as e power log base ex minus log base e2. So x by 2 power x that can be written as e power x into ln x minus ln 2. And similarly 2 by x power x that will be minus of this. So this will be e power minus x into ln x minus ln 2. So now therefore if we take this x ln x minus x ln 2 as t suppose, so then the x by x plus ln x minus ln 2 into dx that is equal to dt. That means ln x plus 1 means I can write ln e minus ln 2 into dx that is equal to dt. So it means I can say this is ln into ex by 2 dx that is equal to dt then. So then obviously this we can write it as e power minus e power t obviously, and this will be written as e power minus t. So therefore this integral if I take it as I, so therefore then integral I can be written as so this part will be dt. So this is e power t plus e power minus t into dt. This integral will come. So then e power t integral, that is e power t, and this will be minus e power minus t plus c. This will be e power t, that is e power x ln x minus x ln 2 minus e power minus of x ln x minus x ln 2 plus c. Now this e power x ln x minus x ln 2, we can write it as x by 2 power x minus this one, we can write it as 2 by x power x. So 2 by x power x plus c. So the answer is x by 2 power x minus 2 by x power x plus c. So option B is the correct answer. Yeah, so here it is told that we have to find the integral I of x, that is equal to integral x plus 1 dx by x into 1 plus x e power x whole square, where x is greater than 0, and it is also told that limit extends to infinity I of x, that would be equal to 0. Then I of 1 we have to find out. So now here we can take 1 plus x e power x as t. So then if we differentiate it, then we will get that x e power x plus e power x, that is equal into dx, that is equal to dt. That means that e power x into x plus 1 dx, that is equal to dt. So therefore the integral I of x can be written as integral x plus 1 dx, that I can write dt by x e power x into t square. Now this x e power x I can write it as t minus 1. So this is integral dt by t square into t minus 1. So this is actually I of t, I can say. So therefore I of t, that is equal to, I can write dt by t square into t minus 1. Now this can be converted into partial fractions, that is 1 by t square into t minus 1, that I can write, that is a by t minus 1, a by t minus 1 plus bt plus c by t square. So then if we take the LCM, then we will get at square plus bt plus c by into t minus 1 by t square into t minus 1, which is equal to 1 by t square into t minus 1. Now if we compare the coefficients of t square and t and the constant on both sides, then we will get, so 1 by t square into t minus 1, that is equal to at square plus bt square t square plus bt square minus bt plus ct, then minus c, divided by t square into t minus 1. So hence therefore I can say a plus b, that is the coefficient of t square, that should be equal to 0, and c minus b, that should be also equal to 0, and minus c, that should be equal to 1. So c should be equal to minus 1. So therefore minus b minus 1, that is equal to 0. So b will be equal to minus 1 also, and so a will be equal to 1. A will be equal to 1. So therefore I can say 1 by t square into t minus 1, that is equal to 1 by t minus 1 and minus of dt plus c, so plus 1 by t square. Minus t minus 1, so it is minus of t plus 1 by t square. That is equal to 1 by t minus 1 minus 1 by t minus 1 by t square. So therefore I of t, that is integral of dt by t minus 1 minus integral dt by t minus integral dt by t square. So that will be equal to log base e t minus 1 mod t minus 1 minus log base e mod t minus this is t power minus 2 plus 1 by minus 2 plus 1 plus c equal to minus 1 by t. So this is equal to actually 1 by t plus log base e mod of t minus 1 by t plus c. Now t is 1 plus x e power x. So therefore I of x, that will be equal to 1 by 1 plus x e power x plus log base e t minus 1, that is x e power x by x e power x plus 1 mod plus c. So now I x tends to 0, we have to find. Therefore now limit x tends to infinity I of x. So that will be limit x tends to infinity. So if this is infinity, that is 0, plus this also will be log base e. You can divide by e power x. So I can write minus of, this will be almost to 1 only. So it will be 1 log base e 1, that is 0 plus c, that is 0. That means that c will be 0. C is 0. So therefore I of x is nothing but 1 by 1 plus x e power x and plus log base e mod x e power x by x e power x plus 1, this one. So therefore now, 1 I of 1, that will be equal to 1 by 1 plus e plus log base e. Log base e, this is e by e plus 1. That means I can say this is 1 by 1 plus e plus log base e, that is 1 plus, no, this will be minus log base e 1 plus e or e plus 1. So this, if we add, if we take the LCM, this will be e plus 1, 1 plus 1 plus e. So this is e plus 2 minus log base e plus 1. So e plus 2 by e plus 1 minus log base e plus 1. So option C is the correct answer. Now here is equal to square into this. Now if I take 1 plus x tan x that is equal to t, then we can say x secant square x plus tan x to dx that is equal to dt. Equal to dt now. So therefore integral, you can write it, integral I of x that can be written as, if we use the integration by parts, then we can say x square into integral dt by t square, then minus dx by x square, that is 2x into integral dt by t square, full integral dx. This will be x square, then the minus 1 by t, minus 1 by 1 plus x tan x, minus integral 2x by plus this will be 2x by 1 plus x tan x to dx. Now this I can again take as I1 suppose. Therefore the integral I of x, I can say this is minus x square by 1 plus x tan x plus I1. Now I1 that will be equal to, now here again we can apply integration by parts, which is 2x I1, I can write it as integral, this I can write sin x by cos x, 2x cos x dx by cos x plus x sin x. Now if we take x sin x plus cos x as z, then I can say sin x plus x cos x plus, okay, obviously then this is minus sin x, x cos x plus sin x minus sin x into dx, that is equal to dz. That means sin x will cancel. So this I can again, so I can write this is 2 integral dz by z. This is 2 log base e mod z obviously plus c. So therefore I1 that is nothing but 2 log base e mod x sin x x sin x plus cos x plus c. So therefore the integral I of x is nothing but minus x square by 1 plus x tan x plus 2 log base e mod cos x plus x sin x plus c. Therefore I of x is nothing but For now, I of 0 that is told, I of 0 is I of 0 that is 0. So this will be, if we put 0 as x, this will be 0 plus this is 0 into 0 plus log 1 that is also 0 plus 0 plus c. So that is also 0. So it means c will be 0. So hence you can say I of x is nothing but this only, which is minus x square by 1 plus x tan x plus 2 log base e mod cos x plus x sin x. This one. Now I of pi by 4. So therefore I of pi by 4 that we have to find. So that will be minus pi square by 16 by 1 plus pi by 4 tan pi by 4 that is 1 plus 2 log base e mod cos pi by 4 that is 1 by root 2 plus pi by 4 to sin pi by 4 is also 1 by root 2. So now this you can write, this is actually minus pi square by 16 into 1 plus pi by 4 and plus this 2 I can take it in the exponent here. So this log base e on this is okay, so this will be, can take the LCM, so this will be pi plus 4 by 4 root 2 whole square. So this will be minus pi square by 4 plus pi. Okay. 4 into 4 plus pi. 4 I can take it inside. 4 4 is 16 plus pi plus log base e pi plus 4 whole square by 16 to the 32. So this will be log base e pi plus 4 whole square by 32 minus pi square by 4 into pi plus 4. Okay. So then obviously option A is the correct answer. It is told f of x is integral 2x dx by x squared plus 1 into x squared plus 3. So then if f of 3 is equal to half of this, then f of 4 is how much? So now this one, so here we can take x square, this integral f of x is integral 2x dx by x squared plus 1 into x squared plus 3 dx. Now here if we take x square as t, then 2x dx that will be equal to dt. So therefore f of t we can write it as integral dt by t plus 1 into t plus 3. Now then we can apply integration, then we can apply this into partial fraction. We can write this as partial fraction 1 plus t into t plus 3. So that is equal to a by t plus 1 plus b by t plus 3. This will be, so a into t plus 3 plus b into t plus 1 by t plus 1 into t plus 3. So if we compare both sides, then therefore I can say the coefficient of t is a plus b, so that will be 0, and 3a plus b, that should be equal to 1. So therefore b should be equal to minus a. So therefore 2a, that would be equal to 1. So a will be equal to half and b will be equal to minus half. So therefore f of t, that will be equal to half of integral dt by t plus 1, then minus half of integral dt by t plus 3. This will be half of log base e mod t plus 1 minus half of log base e mod t plus 3 plus c obviously. So then therefore f of x that can be written as half of log base e mod of should be 1 plus x square plus t is x square, so x square plus 1 minus half of log base e mod x square plus 3 plus c. This is nothing but 1 by 2 log base e mod x square plus 1 by x square plus 3 plus c. So this is f of x. Now f of 3. So therefore now f of 3 that is equal to half of log base e 3 square, so 9 plus 1 by 9 plus 3 plus c. So which is equal to, given as this is okay, so this is half of log base e 10 by 12, so that is plus c, so 2 5 are 10, 2 6 are 12, so which is equal to half of log base e 5 minus log base e 6 plus c. So hence we can say c will be equal to 0. So therefore the function f of x is 1 by 2 log base e mod x square plus 1 by x square plus 3 only. And f of 4 will be how much? So therefore f of 4 that is equal to half of log base e 16 plus 1 by 16 plus 3. So this will be half of log base e 17 by 19. Which is equal to half of log base e 17 minus log base e 19. 17 minus 19. So option D is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year JEE Mains exams. Still any doubts if you have, then please write that in the comments, and in any other chapter of maths also if you have any difficulty, then please write the name of that chapter also in the comments. So okay. So thank you everyone. Bye.